Okay, so in this video, I would like to do an example of a volume of solid of revolution problem. And in this problem, we're going to be finding the volume of the solid that we get when we rotate the region bounded by this equation. So x equals square root of 5 minus y squared, and x equals 1 about the y-axis. Okay, so it's always helpful with problems like this to first think about a picture of what's going on here. So the first thing we have is we have our equation x equals square root of 5 minus y squared. And it might be difficult to recognize this at first, but if we try to get the x and the y on the same side here, right? So I have x equals square root of 5 minus y squared. And if I square both sides of this, I'm going to get x squared is equal to 5 minus y squared. And then if I add the y squared to both sides, I get x squared plus y squared is equal to 5. So this is actually the equation of a circle. So this is giving me a circle around the origin, kind of like this. And then in my original equation, I have x is equal to the square root of something. So this right here, this means that x is only going to be positive. So even though this one down here is the equation of a complete circle, this guy, this first equation, is the part of the circle where x is positive. So that's just this part right here. Okay. So we have this curve, and then we have x is equal to 1. So somewhere in here we have x is equal to 1. Okay, and so the region that we're actually dealing with is the region that's bounded by these two curves. So this is what we're rotating, and we're rotating this around the y-axis like this. Okay. So what would be the easiest way to find the volume? Well, we know that we have disks or washers. Those are our two methods. And usually you want to use whatever variable you started with, right? So in this case, I started with x is equal to square root of 5 minus y squared. So I already kind of have things in terms of like a function of y. So that tells me that my variable of integration in my integral is probably going to need to be y. That would be the easiest thing. So imagine, let's look at this picture again. And so we're integrating this with respect to y, right? And you can kind of think of that as like we're taking these like horizontal pieces of our region, and our integration is adding up a bunch of these little horizontal pieces here. Right? So it's like if I'm integrating with respect to x, then I'm always taking vertical slices of something and I'm adding those up. But if I'm integrating with respect to y, right, I'm taking horizontal slices, and this little piece here is like my dy, right? So let's come down here. So I know I want to integrate with respect to y, and that's going to give me these little horizontal pieces that I'm rotating around here. So that kind of looks like I'm going to need to do washers, right? Because if I take a flat horizontal slice of my region and I rotate it around, right, that's giving me the shape of a washer, sort of like that. Okay, so I'm going to do washers. So let's recall that the formula for area when you use washers is we have the integral of pi, and then times our outer radius squared, and then minus our inner radius squared. So inner, and in this case it's dy. And we'll find the bounds of integration. But so I know what my outer radius is going to be, right? I know that this is going to be whichever function was further out, right? So that's going to be the square root of 5 minus y squared. And then my inner is going to be whichever one was further in, so that was just 1. Okay. So now we're almost ready to do our integral here. We just need to find the bounds, right? And so to find the bounds, we just need to find, where these two guys are intersecting. So we need to find the intersection between square root of 5 minus y squared and then x equals 1. So that's going to happen when these are equal. If I square both sides here, I'm going to get 5 minus y squared is equal to 1. And then we just kind of want to simplify, right? Add y squared to both sides. So 5 is 1 plus y squared. That means that 4 is equal to y squared, and that means that y is equal to plus or minus 2. Okay, so to recap, we found our bounds of integration here. We know what our outer radius is, and we know what our inner radius is. So the only thing that's left to do is to just do the integral. So I have integral over -2 to 2. Then I have pi. My outer radius is square root of 5 minus y squared. So if I square that, I'll just have 5 minus y squared, like that. And then I take away my inner radius squared, which is just 1. So I'm integrating this dy. So now we just want to simplify. Notice that this pi is just a constant. So whenever you have a constant that's multiplying everything inside the integral, you can just pull that out. So I'll just put the pi out in front. Okay, and then on the inside here, I have 4 minus y squared dy. Okay, so now we just want to integrate this using the power rule. The integral of 4 is going to be 4y, because we're doing the integral dy. And then the integral of, I have minus y squared, so that's going to become minus y to the third over 3. So just using the power rule. Okay, and then if I evaluate this over my different bounds, first of all, so 4y when y is equal to 2. So I'm going to have 4 times 2. And then minus 2 to the third over 3. And then remember, we want to subtract, and then we want to evaluate at the lower bound. So we want to evaluate at the lower bound of -2. So that's going to give me 4 times -2. And then I'm going to subtract -2 to the third over 3. Okay, so now we want to simplify things a little bit here. So I still have my pi out in front. And then on the inside here, so I have 4 times 2, so that's just going to give me 8. Here I'm taking away 8/3. And then if you simplify these here with the negative, I'm going to have plus 8. And then I'm going to have minus 8 over 3. So that's how all of that's going to come out. Okay, and then we're almost done. So we're going to have pi. Here I have 16, and then minus 8/3 minus 8/3. So that's the same as 16 is the same as 48 thirds, and then minus 16 thirds. So that's going to give me 32 over 3 on the inside. So my final answer is 32 pi over 3. And that's the volume. And that's it. Thank you very much for watching.